Look at this. A cold, dark, and lonely cloud of gas and dust. 4.6 billion years ago, this was your home. It's called the Solar Nebula. Most of it was hydrogen and helium, leftovers from the Big Bang, mixed with ancient stardust. Left to its own devices, this cloud might have stayed this way forever. But then, something nearby died. A massive star reached the end of its life and went supernova. The shockwave slammed into our quiet cloud like a cosmic sledgehammer. Gravity, which was previously balanced, suddenly took over. The nebula began to collapse in on itself, spinning faster and faster. Think of it like a figure skater pulling in their arms, or better yet, a giant cosmic pizza dough being flattened into a disc. 99.8% of all the material rushed to the center. The leftover 0.2%? That's everything else. Including you. At the center, the pressure and temperature skyrocketed. Our sun was being born, but it wasn't a star yet. It was a protostar. While the sun was hogging the spotlight, the rest of the disk was a mess of dust and gas. Something was happening at the microscopic level. Static electricity, the same stuff that makes your hair stand up, helped these tiny grains stick together into pebbles. Pebbles became rocks. Rocks became boulders. This is called accretion. It's like building a planet out of cosmic Legos. But this wasn't peaceful. It was a 100 million year demolition derby. Millions of protoplanets were fighting for space. Only the biggest survived by eating their neighbors. If you weren't big enough to be a planet, you were lunch. In the center, our proto-sun was getting ready for its big reveal. The heat was becoming unbearable. And then, boom! The sun turned on. And the real chaos was just beginning. When the sun ignited, it didn't just bring light. It unleashed a ferocious solar wind, a stream of particles moving at millions of miles per hour. This cosmic leaf blower blasted the inner solar system clean, pushing the lighter hydrogen and helium gas into the outer reaches. This created a divide. Inside, only heavy materials like rock and metal could stay. Outside, the giants were waiting to feast on the gas. In the inner system, the seeds of Earth, Mars, Venus, and Mercury were colliding. These were called planetesimals. It was a game of orbital bumper cars. Protoplanets the size of the moon would smash together to form bigger worlds. Early Earth was unrecognizable, a hellish ball of molten lava with no water and no atmosphere, constantly bombarded by space rocks. As Earth grew, it melted completely. Heavy iron and nickel sank to the center to form the core, while lighter rocks floated to the top. But while the inner planets were struggling to stay solid, a monster was growing in the shadows, Jupiter. Jupiter grew so fast it became 10 times the size of Earth in just a few million years. It was the first planet to reach maturity. Jupiter wasn't just a planet, it was a gravitational bully. It started to move, wandering toward the sun like a cosmic wrecking ball. This migration nearly destroyed everything. Jupiter's gravity scattered the asteroids and stunted the growth of Mars. It was like a toddler walking through a Lego city. Everything the inner planets were building was being kicked around. Thankfully, Jupiter had a younger sibling. Saturn was also growing, and its gravity eventually pulled Jupiter back out. With the giants finally in their places, the inner planets could finally finish growing in peace. Well, mostly. Because one last, massive collision was about to change Earth forever. And it's the reason we have a moon. Meet Theia. A planet the size of Mars, on a direct collision course with a young, molten Earth. This wasn't just a hit, it was a total planetary reset. The impact was so violent it liquefied both planets instantly. Theia's core sank into Earth, but a massive ring of vaporized rock was kicked out into orbit. Earth briefly looked like Saturn. In less than a century, a blink in cosmic time, gravity pulled this ring together to form the Moon. Earth wasn't alone anymore. This new companion would eventually stabilize our tilt and create the tides we see today. But what about the rocks that never became planets? Locked between Mars and Jupiter, we find the failures of the system. These asteroids are cosmic time capsules. They are the original materials from the Solar Nebula, frozen in time for billions of years. They wanted to become a planet, but Jupiter's gravity kept stirring the pot, smashing them together too fast to stick. Further out, we crossed the frost line. Here, it was cold enough for water, methane, and ammonia to freeze into solid ice. This gave the outer planets a massive advantage. They didn't just have rocks, they had mountains of snow and ice to build with. With so much solid material, their cores grew huge, fast. Once they hit about 10 times Earth's mass, they started grabbing gas. Saturn followed Jupiter's lead, vacuuming up the leftovers and creating its iconic rings from captured ice and debris. Uranus and Neptune, the ice giants, formed further out where gas was thinner. They are mostly made of hot, dense, icy fluids. By now, the solar system had its main cast of characters. But the orbits weren't where they are today. Not even close. The giants were about to play a game of musical chairs that would send billions of comets screaming toward Earth. For millions of years, the solar system was a ticking time bomb. The gas giants were trapped in a gravitational tug-of-war. The math tells us something crazy happened. Jupiter and Saturn hit a 2-to-1 resonance. Every time Jupiter circled the Sun twice, Saturn did it once. This sync-up acted like a cosmic kick. It destabilized the whole outer system, throwing the orbits of Uranus and Neptune into a frenzy. The giants moved. Neptune and Uranus were pushed out, plowing into a thick belt of icy comets at the edge of the system. Billions of icy rocks were sent screaming toward the inner planets. This was the late heavy bombardment. For Earth, this was a disaster, and a gift. These comets may have been the cosmic delivery trucks that brought us our water. Every glass of water you drink might have started its journey 4 billion years ago in the frozen outskirts of space. The chaos finally settled. Jupiter and Saturn moved into the stable orbits they hold today, acting as gravitational guardians for the inner worlds. What was left behind? The asteroid belt, the rubble of a planet that never was, pinned between Mars and Jupiter. To us, these rocks look like trash. But to scientists, they are time capsules, containing the original ingredients of the Solar Nebula. Even further out, the Kuiper Belt remained, a frozen graveyard of icy worlds like Pluto, leftovers from the system's formation. It's cold out here. Really cold. These objects haven't changed much in 4 billion years. They are the solar system's deep freezer. After 100 million years of chaos, the solar system finally reached its mature form. The construction was done. Now, life could begin. But we shouldn't get too comfortable. In the cosmic scale, stable is a relative term. The universe always has another move. Because in about 5 billion years, the Sun is going to have a very big, very red midlife crisis. You might be wondering, how do we know all this? We weren't there with a camera 4.6 billion years ago. Or were we? In the high deserts of Chile, the ALMA telescope array looks deep into space to find other solar systems being born right now. This is Tauri. It's a real image of a star just 1 million years old, surrounded by a disk with clear gaps, where planets are currently forming. It's like looking into a cosmic ultrasound.
Much like the
we are seeing our own
Tauri
past mirrored in the stars across the galaxy. And then there's James Webb. It uses infrared light to peer through the thick dust that blocks our view of stellar nurseries. With Webb, we can see the water and organic molecules hidden in the chaos. We are finding the same ingredients everywhere. Closer to home, meteorites are our most reliable witnesses. They contain chondrules, tiny beads of molten rock from the very start. By dating these beads, we've nailed down the age of the solar system to exactly 4.567 billion years. Give or take a few weekends. But we've also learned that our solar system is a bit of an weirdo. Most other systems look nothing like ours. Where are the super-Earths here? Why is our Jupiter so far out? The more we see, the more we realize how lucky we were. If Jupiter hadn't tacked, moving in and then back out, Earth might never have had the space or the materials to form at all. Jupiter is the reason we are here, and the reason we aren't currently being pummeled by every comet in the sky. So, we have a stable star, a protective giant, and a moon that keeps us steady. It's the perfect cosmic apartment. But remember, our lease isn't permanent. In the long run, the very sun that gave us life will become our biggest threat. Ready to see how the story ends? Let's jump 5 billion years into the future. For 5 billion years, our sun has been a perfect host. But it's running out of the very fuel that keeps it stable, hydrogen. Deep in the core, the hydrogen is being crushed into helium. When the hydrogen runs out, gravity will start to win the battle. The core will shrink, but the outer layers will do the opposite. The sun will bloat into a massive, angry red giant. Mercury and Venus will be the first to go, swallowed whole by the sun's expanding atmosphere. Talk about a bad day for them. For Earth, the oceans will boil away, and the atmosphere will be stripped into space. Our home will become a charred cinder. But there's a silver lining. As the inner system burns, the frozen outer moons, like Titan and Enceladus, will finally warm up. For a few 100 million years, the outer solar system could become the new prime real estate of the galaxy. But even this won't last. Eventually, the sun will shed its outer layers, blowing them off into space in a beautiful, colorful nebula. Left behind at the center is the sun's core. A small, dense, and incredibly hot white dwarf. The ghost of our star. Our massive, chaotic system will be reduced to a graveyard. A cold white dwarf orbited by frozen, dead rocks. But remember how we started? A cloud of gas and dust from a dead star. The cycle continues. Your carbon, your iron, your calcium, they will all be returned to the galaxy to build new worlds. New Earths. Maybe even new hues. We are a brief, beautiful moment in a 100 million year construction project that never really ends. The chaos was violent. The collisions were brutal. But look at what they created. Look at where you are right now. The story of our solar system is your story. And it's the most epic construction project in the universe. We've seen the birth and the death of our home. But even now, 4.6 billion years later, the solar system is hiding secrets in the dark. Beyond Neptune lies the Kuiper Belt. It's home to dwarf planets like Pluto, Eris, and Haumea, frozen leftovers that never quite made it to the big leagues. But scientists noticed something strange. Many of these icy worlds are being pulled by an invisible gravity. Something big is out there. A hypothetical Planet 9. A world 5 to 10 times the mass of Earth, lurking in the shadows 20 times further than Neptune. Is it a captured exoplanet? A baby black hole? Or just a ghost in our data? We are currently hunting for it with every telescope we have. But even Planet 9 isn't the end. Further still is the Oort cloud, a giant shell of trillions of icy comets surrounding the entire solar system. This is the true edge of the sun's kingdom. It's so far away that a comet here takes thousands of years to complete one orbit. When a passing star nudges one of these ice balls, it falls toward the sun, becoming a comet that we see in our night sky. So, our solar system is much bigger and more complex than the 8 planets you learned about in school.
And the massive Oort cloud extend.
Even our fastest spacecraft, Voyager 1, will take another 30,000 years just to pass through the Oort cloud. We've barely scratched the surface. Every star you see in the night sky is likely its own construction project. Trillions of planets, each with its own chaotic story. Are they like us? Or are we the lucky exception in a universe of giants and fire? We are just beginning to find out. Next time you look at the moon or the sun, remember the 100 million years of violence it took to put them there. You aren't just an observer of the universe. You are a part of it. A survivor of the chaos. Thanks for exploring the chaos with me. Keep looking up. To truly understand the 100 million year chaos, we need to talk about scale. If the sun were the size of a soccer ball, Earth would be a tiny grain of sand, located about 27 meters away. That's roughly the length of 2 school buses. Jupiter? That would be a cherry tomato, sitting nearly 140 meters away, about 1.5 football fields from our soccer ball sun. And Pluto? A microscopic speck of dust, over a kilometer away. The solar system is mostly just empty space. But remember, the original nebula was thousands of times larger than this. Most of that material was lost to the stars. Now look at the time. If the history of our system was a 24-hour clock, the 100 million year chaos happened in the first 30 minutes. Life didn't even show up until mid-afternoon. And humans? We only appeared in the very last second before midnight. Every atom in that last second was forged in the chaos of that first half hour. You are ancient history, walking around. We owe our lives to the bullies like Jupiter that moved at just the right time, and the collisions that gave us our moon. Our home is a masterpiece of physics, built from the wreckage of a violent past. And it's the only one we've got. So take a moment to look up tonight. You aren't just looking at the stars. You're looking at your origin story. The chaos is over for now. But the universe is still building. Who knows what's next?